Skilla. Enhancing careers. Chapter 3. Flight planning and preparation. Flight planning and preparation are crucial for safety, efficiency, and cost-effectiveness in flight operations. This process involves calculating the safest and most efficient routes, considering factors like weather, airspace restrictions, and aircraft performance to prevent incidents like fuel shortages or turbulence, while also optimizing costs by improving fuel efficiency and reducing delays. The flight planning process is a critical component of flight operations that ensures safe, efficient, and compliant flight execution. Here's an overview. Pre-flight planning. Gathering weather forecasts, NOTAMs, notices to airmen, and air traffic information. Route planning. Determining the most efficient route, considering factors like weather, air traffic control restrictions, fuel efficiency, and aircraft performance. Altitude and speed planning. Selecting optimal altitudes and speeds for fuel efficiency and safety. Fuel planning. Calculating fuel requirements based on route, weather, and aircraft performance. Weight and balance. Ensuring proper weight distribution and balance for safe flight operations. Performance planning. Evaluating aircraft performance capabilities for takeoff, climb, cruise, and landing. Regulatory compliance. Ensuring adherence to aviation regulations, such as flight time limitations and rest requirements. Crew briefing. Providing pilots with necessary information, including weather, NOTAMs, and emergency procedures. Pre-flight preparation. Pre-flight preparation is an essential preliminary to all flights. Usually, it comprises the following 5 stages. AIS/AIP briefing. Meteorological briefing. Route selection. Chart preparation. Flight plan preparation. AIS briefing. AIS briefing involves identifying all aeronautical information which may affect the flight. This comprises of permanent aeronautical information contained in National Aeronautical Information Publications, AIPs, or commercial flight guides and printed on aeronautical charts, and temporary information contained in NOTAMs, AICs, etc. Most aerodromes contain briefing facilities for use by pilots preparing for a flight. There is also a direct link to a central aeronautical library for an online access to aeronautical information may be available. The contents of AIPs are laid down by ICAO standards. However, national AIPs are of limited geographical coverage and commercial flight guides are usually more convenient to use. AIP. An Aeronautical Information Publication, AIP, is a publication issued by or with the authority of a state and containing aeronautical information of a lasting character essential to air navigation as per ICAO Annex 15. The AIP contains details of regulations, procedures, and other information pertinent to the operation of aircraft in the particular country to which it relates. It is usually issued by or on behalf of the respective Civil Aviation Administration and constitutes the basic information source for permanent information and long-duration temporary changes. The structure and contents of the document are standardized by international agreement through ICAO. AIPs normally have 3 parts: Gen, General, ENR, En route, and AD, Aerodromes. The documents contain many charts. Most of these are in the AD section where details and charts of all public aerodromes are published. Meteorological briefing. Meteorological briefing involves determining forecast and actual weather conditions for the route planned and for selected airfields along the route. En route weather comprises forecast winds and temperatures at cruising levels along the route together with forecasts of en route weather conditions, especially cloud conditions, and any associated turbulence and icing. This information is depicted on special charts. Airfield weather reports may be either actual reports, Meteorological Terminal Air Report, METR, or forecast conditions, TAF. METRs are issued at regular intervals. When a significant change to conditions occurs before the next METR is due, a special report, SPICY, is issued. In the interests of brevity and clarity, written METRs, SPICYs, and TAFs always follow the same format and employ simple self-evident codes. If the aerodrome has a fully staffed meteorological office, a forecaster may be available to explain the forecast and any expected hazards. Where briefing is by reference to printed matter only, a degree of expertise is necessary to decode the various different types of information. Route selection. When choosing the route for a flight, the following considerations must be taken into account where applicable. Flights across national boundaries. Flights which will cross national boundaries must obey the relevant regulations contained in national AIPs. Controlled airspace. Flights to be conducted wholly or partly within controlled airspace must follow the provisions of the appropriate national authorities contained in the national AIP. Airspace restrictions. Flights must avoid airspace restrictions, including danger, prohibited and restricted areas, and other flight restrictions. RVSM airspace. Reduced vertical separation minima, RVSM. Airspace must be avoided when operating aircraft when approval has not been granted. Weather. Where possible, the route should avoid areas of forecast extreme weather conditions, e.g. severe turbulence or moderate or severe icing. Weather conditions at the departure. Estimation and alternate airfields must be better than the specified minima. Navigation equipment in the aircraft must be adequate for safe operation in accordance with national AIPs. Equipment serviceability must satisfy the relevant MEL. Where visual navigation is to be employed, the route should avoid areas of low cloud or areas where visibility is forecast to be poor. Where navigation is to be by use of radio navigation aids, the route may be designed to follow tracks between radio beacons. Over water flights. Special rules apply to flights over water. Flights across the North Atlantic above specified flight levels must conform to the North Atlantic track structure. Flights by twin-engine aircraft may be required to route in accordance with extended-range twin-engine operation procedures. Chart preparation. Following conditions apply while preparing the charts. Charts used must be marked with all relevant airspace restrictions, i.e. controlled airspace, danger, prohibited, and restricted areas. Charts printed with aeronautical information must be checked to ensure the currency of depicted information. Temporary airspace restrictions notified in NOTAMs or AICs must be marked on charts. The route to be flown should be marked on charts, including, where appropriate, topographical charts. Where appropriate, important bearings or ranges from navigational beacons should be marked on the chart. See also navigation by radio aids. Flight plan preparation. Where required by national procedures and instrument flight rules, IFR, or visual flight rules, VFR. Flight plan should be prepared for submission to ATC authorities. The ATC flight plan must be submitted in good time, as specified in the national AIP. Whether or not an ATC flight plan is required, a navigation flight plan should be prepared for the route, showing planned levels, minimum safe flight levels, tracks, distances, times, ETAs and fuel requirements, and any other information specified by the operator. Weather forecasting and risk assessment. Weather forecasting and risk assessment are crucial in flight operations to ensure safe and efficient flight execution. By integrating weather forecasting and risk assessment, flight operations can minimize weather-related risks and ensure safe and efficient flight execution. For weather forecasting, following processes are followed. Pre-flight planning. Pilots and dispatchers gather weather forecasts, warnings, and advisories for the route, departure, and arrival airports. Weather briefings. Pilots receive detailed weather briefings, including current weather conditions, forecasts, and potential hazards like turbulence, icing, or thunderstorms. In-flight updates. Pilots receive updates on weather conditions en route, enabling them to adjust their flight plan if necessary. Steps followed for risk assessment are as follows. Weather-related hazards. Pilots assess risks associated with weather conditions, such as turbulence, icing, thunderstorms, or low visibility. Route evaluation. Pilots evaluate the route for potential weather-related risks and plan alternative routes if necessary. Aircraft performance. Pilots consider the aircraft's performance capabilities in various weather conditions. Fuel planning. Pilots plan for potential weather-related delays or route changes, ensuring sufficient fuel reserves. Decision-making. Pilots make informed decisions about flight planning, delaying, or canceling flights based on weather forecasts and risk assessments. To streamline the above processes, flight planning software and tools are often used to improve accuracy. Tools and technologies that are used in flight operations are weather radar. Pilots use weather radar systems to detect precipitation and other weather phenomena. Forecasting models. Dispatchers and pilots use forecasting models, such as numerical weather prediction models, to predict weather patterns. Weather apps. Pilots use weather apps, like ForeFlight or Garmin, to access weather forecasts, warnings, and advisories. Risk assessment tools. Airlines and pilots use risk assessment tools, such as safety management systems, SMS, to evaluate and mitigate weather-related risks. Aircraft performance. Aircraft performance and loading are critical factors in flight operations, directly impacting safety, efficiency, and compliance. Here's an overview. Takeoff and landing performance. Calculating required runway lengths, climb rates, and obstacle clearance. Climb and cruise performance. Evaluating rate of climb, cruise speed, and fuel efficiency. Descent and approach performance. Planning descent rates, altitudes, and approach speeds. Aircraft limitations. Understanding aircraft performance limitations, such as maximum altitude, airspeed, and weight. Loading, weight, and balance. Calculating the aircraft's weight and balance to ensure safe operation. Payload capacity. Determining the maximum payload, passengers, cargo, fuel, the aircraft can safely carry. Fuel loading. Calculating fuel requirements for the flight, including reserves. Load planning. Planning the distribution of payload and fuel to maintain safe. Weight and balance. Factors affecting performance and loading. Weather. Weather conditions, such as temperature, wind, and precipitation, impact aircraft performance. Air density. Air density affects aircraft performance, particularly during takeoff and climb. Airport elevation. Airport elevation impacts aircraft performance, particularly during takeoff and landing. Aircraft configuration. Aircraft configuration, such as flap and slat settings, affects performance. Tools and technologies. Performance charts. Pilots use performance charts to calculate aircraft performance capabilities. Flight management systems, FMS. FMS systems provide performance data and guidance. Load planning software. Airlines use load planning software to optimize payload and fuel loading. Aircraft performance monitoring. Some aircraft have performance monitoring systems that track and analyze performance data. By understanding aircraft performance and loading, flight operations can ensure safe, efficient, and compliant flight execution.